In this video, I'll be helping you with the ALEKS problem type called completing Gauss-Jordan elimination with a 3x3 matrix. Here we are given our system of linear equations, 3 variables and 3 equations, and we can see that that's already been translated into our augmented matrix where the coefficients in front of x are in the first column, the coefficients in front of y are in the second column, the coefficients in front of z are in the third column, and the constants are in this fourth column. And we notice that since some of these variables aren't present in those equations, the coefficients there are 0. And now that we have this augmented matrix, we can start doing our transformations to turn this left side into the identity matrix with ones along that diagonal. You can see that in the first step, the goal has been to make this first element a 1. It was a 4, and to turn it into a 1, the entire first row must have been multiplied by 1/4. So 1/4 times 4 would have given me the 1. 1/4 times 0 would still be 0. 1/4 times -2, a -1/2. 1/4 times 4, a 1. So with row multiplication, we multiplied by 1/4, and we now have a 1 in that first space. In our second step, we have eliminated this third cell, making it a 0. And to do so, we are multiplying this new row 1 and adding it to row 3. In order to cancel this 5, I would have to multiply that row 1 by a -5. So -5 times 1 would be -5 plus that 5 would cancel to 0. So I know this is -5 times that first row. And I notice that afterwards -5 times 0 would be 0 plus 2, still 2. -5 times 1/2 would be 5/2 plus -4 is that -3/2. And -5 times 1 would be -5. Plus 28, our 23. So our second step is completed. From here, next we are transforming this 3 in row 2 into a 1. And to do so, I can just multiply that entire row by 1/3. So 1/3 times 0 is still 0. 1/3 times 3 is 1. 1/3 times 1 is 1/3. And 1/3 times 15 is 5. So we have continued our transformation. Next, we are modifying row 2 so that we can add it to row 3 to cancel out the 2 and have it become a 0. So I would need to multiply row 2 by a -2 in order to cancel whenever I add it to row 3. -2 times 0 is 0. Adding to 0, still 0. -2 times 1 is -2, plus 2 gives us the 0. -2 times 1/3 is -2/3, plus a -3/2 gives us our -13/6. And -2 times 5 is -10, plus the 23 is our 13. So again, we are one step closer here. Next, we can see that we are multiplying row 3 by a coefficient. In order to turn this element into a 1, I would need to multiply by the negative reciprocal, -6/13, in order for that to become a 1. Multiplying by 0 gives us 0. Again, multiplying by 0 is 0. -6/13 times -13/6. The negatives cancel. The numerators and denominators cancel to give us just a 1, and then -6/13 times 13 would give us our -6. So our multiplying coefficient here is -6/13. Next, we're told that row 3 is multiplied by 1/2 and added to row 1. So multiplying by 1/2 times 0 is 0. Plus the element in row 1 is 1. 1/2 times 0 is 0 plus 0, again 0. 1/2 times 1 is 1/2 plus the -1/2 is 0, and 1/2 times -6 is -3, plus 1 is a -2. So our top row is established. And the next question is, what would we multiply row 3 by to add to row 2? Here we are trying to cancel out this 1/3. So I would multiply by a -1/3. -1/3 times 0 is 0, plus 0 is 0. -1/3 times 0 is 0 plus 1, which is 1. -1/3 times 1 is -1/3, plus a +1/3 gives us that 0. And -1/3 times a -6 is a +2, plus 5 is 7. And then lastly, our third row here is already in row echelon form, so we didn't need to make any changes there. The third row is equal to -6. So 1x equals -2, x is -2, 1y equals 7, so y is 7, and 1z equals -6, so z is -6.